Welcome to Ask and Learn.
Well, we see this rig has cables and loads on the beam, the boom of the going from A, C, D, and E points B. The boom goes from A, B to C, and the cable wraps from point A over D, C, and down to the ground point F. We have loads of the average weight of the boom is 1,200 pounds. We have a crate of 3,600 pounds acting on the boom. So we're asked to solve for the tension in the cable that makes the minimum couple at the base of the rig. So if we look at all the 7 forces reacting at base E, 5 of them are from the cable and 2 are from the boom load. If we solve for the net moment from the base about the cable first, put it in terms of T, the tension in the cable. If we break the forces into XY components using trig functions, reveals about points A, B, D, and C, we get the force in the first A in the X direction is 17.5 divided by the hypotenuse times T, which is 0.9615 T. In the Y direction, we get 5 divided by the hypotenuse, which is 0.275 T. At point D, the reaction of that cable is exactly opposite of what it is at A. So we have negative FA1x, negative FA1y for the forces at D from cable 1. The second cable attaches to point D also. So we do the trig for that cable going down. We have a force at D in the X direction is 3.75 divided by hypotenuse, or 0.66 T. And the point D in the on the Y is 5 divided by hypotenuse, or 0.8 T. At point C, we get the negative of that force acting at X and Y location. So the FC1X load is negative FD2X. FC1Y is just negative FD2Y, since they balance each other. The force from the cable in the X direction at point C is 0 because it's all vertical on the second cable, and have the negative tension in the Y direction. So we need to find the net moment of the base based on these 10 loads using their moment arms. So at point A, we have 0.9615 T times 10 foot, which is 9.615 T. Moment at point A, the Y direction from point cable 1 is 0.275 times 17.5, its moment arm, which is 4.8125 T. The moment about from point D acting in the X direction is 0.9615 times 15, which is negative 14.4 T. The force in the D in the Y direction, cable 1, is 0.275 T, which is 0, because it's all acting straight downward through the base. The moment about point D in the X direction from cable 2 is 15 times 6T, which is 0.6T, which is 9T foot-pounds. And in the Y direction, it's also 0 because it's straight through the base. The reaction at point C from the cable 1 is negative 0.6 times 10, which is negative 6T. The cable tension in the Y direction from load 1 is 8.8 times 3.75, which is negative 3T. So, last but not least, the cable going down to the ground, MC2X is going to be 0 the moment, because there's no acting couple. and the moment MC2Y is 3.75 T a moment arm. So for a total summing these 10 moments up, you get 3.7775 T foot-pounds of tension, moment of positive about the base. To minimize the moment at the base, use the average moment from the two loads on the boom to balance the tension exactly. So if you take the moments at the extreme points are 1200 times 6.5 and plus minus 1.5 times 3600, so you get 13200 negative. The maximum is 1200 times 6.5 and 17.5 times 3600, so negative 7800. Adding these and dividing by 2 gives you an average of 42,000 foot-pounds moment negative at point E. If the cable set counters the average between these two cables tension to be 42,000 divided by the 3.7775. In other words, the tension in the cable to fight the average load ends up being 11,118 pounds tension in the cable. Since this balances the average load precisely, the maximum load would then be the difference between the 42,000 average and the peak of 7,800, or 28,800 foot-pounds at the base, the couple. That's all.